Okay, chapter 7 is about radical expressions, and this section is about radicals and the radical expressions. Okay, the radical expression is there is nth root symbol, the radical symbol. So in this case, nth root of a. Okay, we call this one nth root of a. So we have seen this one square root of, let's say, square root of 4. Okay, we can read this one as square root of 4. So basically the index is 2. So usually we don't write the index if the index is 2. So we just omit the index number 2. So we can write it like this, square root of 4. And the index is 3, then we can write it as this, cube root of 8, cube root of 8. Then this is equal to cube root of 8 is 2 cubed. 2 cubed. So since the index and the exponent of the radicand is same, then we can take this base out, 2 out. And square root of 4 is the same. Square root of 4. 4 is 2 squared. And the radicand, the power of the radicand is 2. And the index is 2. The index is not shown here, but if it's not shown, then the index is 2. So we can cancel out this index and the exponent so that the base can get out. Okay, let's do a little bit more examples. Okay, what about this? Okay, here is very important thing. If the index is even, like a square root or fourth root, then the radicand has to be always non-negative, positive or 0. It cannot be a negative. So here's a square root of -4. Okay, square root of -4. The index is even. Since this is square root, the index is even, so that the radicand has to be positive. Then this is not a real number. Okay, this is not a real number. And this is an imaginary number. Imaginary. So in this case, we cannot write this one as a real number. So if the index is even, make sure the radicand is positive. How about this? About square root. Okay, we don't write the index if it is square root, but let me write it here for example. So square root of, how about this one? -2 squared. Is the radicand positive or negative? The radicand is positive because -2 squared is actually -2 times -2 is +4. And the +4 is square root of 2 squared. So this is equal to 2. -2 squared is positive, so this is a real number. It's not an imaginary number. So since this is positive, -2 squared is positive, then we can square this 4 again, so it becomes 2 squared. So this is equal to 2. Okay, how about if the radicand is, if the index is cube root? Okay, cube root of 8 is, we know that this is cube root of 2 cube is 2. How about the cube root of -8? Okay, if the index is odd, I'm sorry, this should be odd. If the index is odd, then the radicand can be any real number. It can be positive or it can be negative. So since the index is 3, the radicand can be a negative. So -8 is okay. Then if the radicand is negative, then the result is negative. So -8 is -2 cube. And then this cube and the index are same, so we can take this base out, -2. So if the index is odd, the radicand can be positive or negative. If the radicand is negative, then the result is negative. If the radicand is positive, then the result is positive. But if the index is even, then always the radicand has to be positive, like this. Radicand has to be positive. Then the result is positive. if the radicand is negative, then this is not a real number, it's an imaginary number. We will do imaginary number in the later sections. So let's not talk about the imaginary number. Okay, so always be careful. Always check the index. If the index is even, what's the condition for the radicand? The radicand has to be positive, cannot be a negative. If the index is odd, then you can use positive or negative radicand. Doesn't matter. Okay, so basically, if the index is, okay, again, index is odd and the radicand is negative, the result is negative. Okay, so index is odd, and the radicand is negative, then the result is negative. The radicand is positive, then then the result is positive. If the index is even, make sure the radicand is always positive, so that the result is positive. If the index is negative, the index is even and the radicand is negative, then this is an imaginary number. This is not a real number. So keep in mind this condition. Okay, let's do some exercise this time. The exercise number 2 in page 354. Okay, square root of 25. Square root. So we can make inside the radicand as perfect squared. So 25 is 5 squared. Then 25 is positive number, so this is a real number. The radicand is positive, so this is okay. The result is 5. Okay, 49 is positive, and this negative is outside the radical symbol. So put the negative sign outside, and then 49 is 7 squared. Okay, 49 is positive. Okay, this is square root. The index is 2. Index is even, so the radicand has to be positive. And 49 is positive, so this is okay. This is a real number. So when we simplify this, the negative sign is outside the square root, so put the negative sign, and then square root of 7 squared is 7. Okay, so negative is outside the square root. Okay, how about this one? This is a square root. The index is even, right? Index is even. Then the radicand has to be positive. This one is positive, it cannot be a negative. So this is not a real number. This is an imaginary number, so just leave it. We will do the imaginary number later. Let me write this one clearly. Square root of negative. The index is 2, right? Even. This is even. So this gotta be positive to become a real number. But since the radicand is negative, it's not a real number. Okay, the number 8. Okay, negative sign is outside, so leave it outside. And then square root of, okay, square root, this is even, and then the radicand is negative, so this is also not a real number. So leave it. Okay, the next one, cube root. The index is odd. If the index is odd, the radicand can be positive or negative, doesn't matter. And then 64 is 4 cubed. So 4 times 4 is 16, 16 times 4 is 64. So this is equal to index, and the power is same, so take the base out. How about this one? Number 12. Okay, the index is 3. 3 is odd number. Odd allows positive or negative radicand. So negative 64 is okay. And negative 64 is negative 4 cubed. So we can take negative 4 out. Since this is negative, the result is negative. As you can see here, you can take this negative 4 out, so the result is negative. Okay, the next one. Negative is outside, and then cube root of 8. 8 is 2 cubed. And the index is odd. So odd allows positive radicand, negative radicand, so 8 is okay, and 8 is 2 cubed, so you can take this 2 out. Make sure to write the negative sign outside. So negative 2. Next one. Okay, negative, same thing, cube root. This is the cube root of negative 64. Okay, cube root, the index is 3, so we can, negative radican is okay. So negative 64 is fine. And negative 64 is what? Negative 4, the whole thing cubed. So the index and the power same, so we can take this base, negative 4, out. So here is the negative sign outside. Then multiply by what? Negative 4. So that is 4. Okay. So always when you simplify a radical, if the index is positive, something to the nth power. So if the index is positive, if n is even, if n is even, then what? This one has to be okay, the radicand, let me write here radicand A. Then A has to be positive. Okay, if n is even, same thing, if n is even, if the n is odd, then A can be positive or A can be also negative. Doesn't matter. Okay, for the index is even. For even index, if what happens if A is less than 0? If A is less than 0, then what? Then nth root of A is not real number. Right? It's not a real number. Okay, I don't have enough space here. It's not a real number. Okay, not real. Not a real number. Okay, this is not a real number. Okay, this example, let's check whether each number is a perfect square, perfect cube, or both, or neither. So, okay, 81 is 9 squared. So this is a perfect square, right? Perfect square. Okay, negative 125 is negative 5 cubed. So this is perfect cube. How about 64? 64 is, it can be a squared. A squared is perfect squared. But 64 is also 4 cubed. 4 cubed. So it can be also perfect cube. Okay, 32 is not a perfect square, and it cannot be written as a perfect square or cube. So this is neither. Okay, here is a inverse property of nth root and nth powers. Okay, this means here is a radical, okay, nth root of A, and this is raised to the nth power. And this power is same as the index. Then the result is only take the radicand out, just A out. Okay, so for example, here's a square root of 5. And this square root of 5 is raised to the second power. Then this power is same as the index 2. So you can take the number 5 out. Very simple. Okay, how about the next one? Now if n is odd, this is odd number. And remember the previous example? N is odd number, so nth root of A to the nth power. This is nth power. So if this is odd, this radicand can be positive or negative, doesn't matter. And the result is same as the sign of this one, the radicand. So in that case, you can take this A out. So here, cube root of 5 cube, then take the base, which is 5, out. Okay, how about this example? It's a cube root of negative 5 cubed. Then index is odd, the power is odd, and they are same. Then take the base out, negative 5. This is simple, very simple. Okay, what about the index is now even? Index is even, and the power, the exponent of the radicand is same as the index. Then you can take this a out, just like that. Take that a out, take that I out, but it's gotta be positive. Make it positive. Why? Because once you raise this number a to the even number, so multiply this a by the even number of times, then it becomes positive. So the result is positive. So like this. The index is 2, and the power is 2. Then this negative 5 becomes what? Positive 5. Make it positive. Why do you make it positive? Because this is equal to square root of, okay, negative 5 squared is 25. And 25 is back to what? 5 squared. The base was negative 5, and this base negative 5 became positive 5. So this is equal to 5. It looks a little bit complicated, but always check the index. Is it odd or even? If it's odd, it doesn't matter. Just take this a out. If it's even, if the index is even, and the power same, then take the base out, but make it positive. Okay, take the base out, and then make it positive. Okay, let's try examples. Okay, this example has 4 examples. Okay, let's try to simplify this. Okay, the first one is square root of 4. Square root of 4, this whole thing is raised to the second power. Then, okay, this is square root. So the power is outside the square root. So that you can take the base out. How about this one? Same thing. The cube root is raised to the third power. So just take this 27 out. Even this one, the fourth root is raised to the fourth power. So take the base, not the base, sorry, the radicand out. Radicand, get radicand out. Even this one, fifth root of something is raised to the fifth power. So take the radicand out. Simple. Okay, in the example 4, let's try the first one. Now the cube root, this is the cube root of something, and the radicand is cubed. Okay, and then the index is even. Index is odd. If the index is odd, what happens? It doesn't matter. Just take the base out. The base inside the square root symbol. So just take 4 out. Okay, and the next one is the index is 3, which is odd. So cube root of something, and this radicand has same power. The power is same as the index. Then it doesn't matter, since the index is odd. If the index is odd, just take the base out. No matter it's positive or negative, it doesn't matter. Index is odd, take the base out. Okay, the next one is okay, this one is, look at this. The square root is raised to the second power. So the power is outside the radical symbol. So since the power exponent and the radical, the index of the radical is same, take the base out. Takes the base out. Okay, how about the last one? Okay, now the radicand is squared. The radicand is squared. The index is square. They're same. Then what do we do? The index is even. The index is even. Index is what? Even. Then what do we do? Take the base out, but make it what? Make it positive. So it becomes 3. Okay, this is important. Index is even. The index is even. then make sure take the base out, but make it positive. Make the base positive. Because when you square negative 3, then it becomes positive. Negative times negative positive. So the radicand is positive. So negative 3 squared is 9. And then if we rewrite this one, that's the square root of 9. And then 9 can be written as 3 squared. So that is equal to 3. So without squaring the negative, just take the base out and then make it positive. Okay, let's do some exercise. Okay, number 32 is square root of 12 squared. Okay, the index is 2 and this is positive, so index is 2, which is even. Then you can take this 12 out, make it positive. So 12 is positive, so leave it. How about, okay, let's use different color. Okay, how about number 38? Okay, square root of negative 12 squared. Index is even, and the index and the power is same. Then you can take the base out, but make the base what? Positive. Because when we square negative 12, it becomes positive already. Okay, how about this one? How about 40? Inside the radicand, this is the square root. The square root allows only the positive radicand, but this is negative. So negative 81, this is the square root of negative 81. This is a negative number. So we say this is not a real number. This is not a real number, and this is what? It's an imaginary number. We can write this one in an imaginary number later. Okay, how about 34? 34 is cube root. Cube root is what? The index is odd, so you can just take the base out. Take the base out. Okay, 36 is the index is odd. The power is same as the index. Then just take the base out. So if the index is odd, it doesn't matter, just take the base out. If the index is even, make sure to change the sign, make sure to make the base out. Base out, base positive. So make sure this base becomes positive. And then also if the index is even, the radicand has to be positive, not negative. Okay, here is a definition of radical exponent. So look at this expression. The exponential expression is 8. The power is 1 over n. The exponent is 1 over n. Then we can write this exponent, exponential expression into a radical. Okay, and if the power, look at the power. The exponent is 1 over n. This is a fraction. Then the denominator goes to the index. So it will be nth root of a. Okay, let me rewrite this. This is equal to, okay, so if this is 1 over nth power, then move this and the denominator to the index. So index is n, so nth root of a. Nth root of a. Okay, how about try this one? Okay, the first one, second, and the second and third are the same actually. So for the second one, okay, let's say the exponent is m over n. Exponent is it's a fraction. Then the denominator goes to where? Okay, we can write it like this: a to the, okay, m over n. M over n is 1 over n times m. 1 over n times m. Then 1 over n is, we can write it as a to the 1 over nth power raised to the mth power. So 1 over n is, so m over n is 1 over n times m. And since the power is product, we can write it as power, some power, a to the some power raised to the mth power, another power. So we can multiply these two exponents, then it becomes m over n. So this is equivalent to what? Okay, the parenthesis is the nth root of a, or nth root of a, and the mth power stays there. So we can write, so in this case we can make it like this. Okay, the n goes to where? N goes to the nth power. The denominator goes to the index. And then you can write a, and then make this whole thing mth power. Or we can do this way, m over n. The exponent is a fraction m over n, and m over n can be written as m times 1 over n. And exponent is a product, so we can make a power to another power. A to the mth power raised to the 1 over n. So we can multiply this m and 1 over n, so it becomes m over n. And then since the base is raised to the 1 over n, this n goes to the index, and then the base stays there. So we can write it as this. A to the m over n, then this n goes to the index, and m stays there. Okay? Can you see it? So this moves to what? To the index. Index. So for example, if we have something like this, get 2 to the 3 over 4, 3 over 4. Then we can write it as the denominator becomes the index, and then 2 cubed. Or you can write it as this. The denominator goes to the index, but you can raise this whole thing to the third power. So this power can get outside the radical symbol. Okay, try another one. Okay, how about 3 to the 2 to the 5th power? Then move this 5 to the index, then it can be 3 squared. Or the denominator 5 goes to the index, and then 3 to the 2nd power. The 2nd power can get outside. Same thing. Okay, how about this? What if we write something like this? Okay, cube root of 2 to the 4th power. Then we can write this radical in an exponential form. Okay, 3 is the denominator of the exponent. So 2 to the 4 over 3. Because 3 is the index, so this index goes to the denominator of the exponent. Okay, how about this? 4th root of 3 to the 5th power. Okay, then this 4 goes to the what? Denominator of the exponent. 3 to the power is 5 over 4. So the exponent is 5 over 1, so this 4 will move to the denominator, like this. So here is the definition of radical exponent. The power, okay, the exponent, the denominator of the exponent goes to the index of the radical symbol. And the numerator of the exponent becomes the power of the radicand. Power of the radicand, or it becomes the power of the whole radical symbol. Okay, in this exercise, let's rewrite each expression in radical form. Okay, radical form. So always move the denominator of the exponent to the index. Then this will be cube root of x. Okay, the exponent is 1 over 4. Then 4 goes to the denominator, goes to the index, so 4th root of x. Okay, 5 is the denominator, that becomes the index. So it'll be fifth root of x, what? X squared. Or you can write it as fifth root of x outside and raised to the squared, to the second power. And the last one, the index is 4, so there will be fourth root of what? U to the fifth power. Or you can write it fourth root of u, then raise everything to the fifth power. Okay, let's evaluate the expressions that has rational exponent. Okay, 8 to the base is 8, so the 8 can be written as 2 cubed, and then raised to the 4/3 power. Then we can multiply the exponent, so 3 times 4/3, then 3 cancel out, 2 to the 4th power, so 16. Okay, the next one. Okay, let's multiply the exponent, so 4 power to another power, so 4 to the 2 times 3/2, then 4 cubed, 2 to cancel out, then 4 cubed is 64. Next one. The exponent is negative. Exponent is negative, then we can move this whole exponential form to the denominator. So 1 over 25, 3/2. And 25 is 5 squared. And then the exponent is 3/2. Then multiply the exponent, 5 to the 2 times 3/2. Then we can cancel out 2, so that is 1 over 5 cubed. So 1 over 125. The next one. Okay, let's assign the power 2 over 3 to each numerator and denominator. So 64 raised to the 2/3 power over 125 raised to the 2/3 power. Then 64 is, we know that is 4 cubed. So 64 is 4 cubed raised to the 2/3 power. And the denominator, 125 is 5 cubed. So 5 cubed is the base, and then 2/3 power. And each numerator denominator is a power to another power. So let's multiply the exponents. 3 times 2/3 over 5 times the exponent is 3 times 2/3. Then 3 cancel out, so 4 squared. The denominator, 3 cancel out, 5 squared. So 4 squared is 16 over 25. Okay, the next one is negative. So negative is outside the exponential form. So put the negative sign outside. And 16 is 4 squared. And 16 is raised to the 1/2. So negative. Okay, multiply the exponent. So 4 to the 2 times 1/2. Then negative. 2 to cancel out. 4. So the answer is -4. Okay, the last one is 1/2. You know, 1/2 is square root of -16. And square root, this is even index. Then we don't allow negative radicand. Since this is negative, this is not a real number. Not a real number. This is an imaginary number. So for the imaginary number, we have a notation for imaginary number. So we will do it later. So make sure if the index is even, the radicand has to be positive. Since the radicand is negative and the index is even, this is not a real number. Okay, in this example, okay, let's simplify these expressions using rational exponents. Okay, so the first one is this is the radical fourth root, so we can write the fourth root into radical rational exponent. Then this 4 moves to the denominator of the exponent. So x to the 3/4. And since the bases are the same, we can add the exponents, 3 over 4. Then x to the 3 over 3 plus 3 over 4. So x to the, okay, 3 over, sorry, this is not right. So 1 is 4 over 4 plus 3 over 4. So that is 7 over 4. 7/4. Okay. The next one. Okay, let's change all the radical expression into an exponential form. The numerator is x to the what? Move this 3 to the denominator of this power 2. So 2/3. The denominator is x to the what? Okay, the index is 2, so we can write it 3 over 2. Okay, 3 over 2. Okay, then we can move the numerator, the exponent. Okay, the exponent of 2 over 3 is less than 3 over 2. So why don't we move this one down? Move it down. Then x to the 3 over 2 times x to the negative 2/3. So that is equal to 1 over x to the power is 3 over 2 minus 2 over 3. Then 1 over x to the, okay, add these two fractions. Then we can make it the denominator 6. So we gotta multiply 3. So 9 over 6 minus, okay, for this, multiply the top and bottom by 2. Then 4 over 6. So that is equal to 1 over x to the 9 minus 4 is 5 over 6. So the exponent is what? 5 over 6. Okay, the next one. Okay, cube root. This is cube root. So we can make the radicand. Radicand, the power is 1 over 3. So the exponent of the radicand is what? 1 over 3. Then assign 1 over 3 to each factor in the base. So x squared raised to the 1/3 power, y raised to the 1/3 power, then x to the what? Multiply 2 exponents. 2 times 1/3 is 2/3 times y to the 1/3 power. Okay, next one. In this case, there is a radical symbol inside the radical. So let's simplify the radical inside. Then cube root of x will be x to the what? 1 over 3. Because this 3 goes to the denominator of the exponent 1. And then this is square root. This is square root. So we can make x to the 1/3 power raised to the what? 1/2. Right? So when we convert this radical square root, then we can make the radicands 1 over 2 power. Then x to the what? Multiply these two fractions. 1 over 6. 1 times 3 over 1 times 2. So 1 over 6. Okay, this one. The base is 2x minus 1. The radicand is 2x minus 1. So why don't we change the denominator, the radical, cube root. So the cube root becomes what? The radicand is 2x minus 1. And then raise it to the what? 1/3 power. And both top and bottom has the same denominator. Same base. Same base, so we can move this one to the numerator. Then 2x minus 1. The power is 4/3. Once we move this one, becomes negative 1/3. So 2x minus 1. 4 minus 1 is 3. 3 over 3 is 1. So we have 2x minus 1. We don't need the parentheses. Okay, let's try this exercise. Okay, negative 121 is, okay, negative is outside the exponential form. So put the negative sign outside. And 121 to the 1/2 power is what? Okay, 121 is 11 squared. And then this was raised to the 1/2. Then negative 11 to the what? Multiply the exponent. Power to power, so multiply the exponent. Then negative 11 to the what? 2 times 1/2 is 1, so that is equal to negative 11. Okay, 65 is negative 27. Okay, negative 27 is negative 3 cubed, right? Negative 3 cubed. And this is raised to the negative 2 to the 5th power. Okay, so that is equal to, we can multiply the two exponents. So negative 3 raised to the 3 times negative 2/5. Then negative 3 to the what? Negative 6/5. Okay, negative 6/5 is, since this is negative, we can move this one to the denominator. Negative 3 to the 6/5. Okay. And negative 3. So, okay, that's it. Okay, I'm sorry. You know what? I copied wrong. Okay, this is 3. The denominator is 3, but I used 5. So this gotta be 3. So let me erase this one and do it again. I'm sorry about this mistake. Okay, so we can write it as this. Okay, negative 27 is negative 3 cubed. And this whole thing is raised to the negative 2/3 power. Okay, then we can multiply the exponents, power to power, so multiply the exponent. Then negative 3 to the 3 times negative 2/3. Then we can cancel out this 3. So we have negative 3 to the negative 2 power. Since the exponent is negative, we can move this whole exponential form to the denominator. So negative 3, the power changes sign. Then 1 over negative 3 squared is positive 9. Okay, the next one. Cube root. So cube root. So let's take this radical out and then raise it to the what? 1/3 power. Then assign the power to each exponent, each factor. Assign this power to each factor. So we have u to the 4th power raised to the 1/3, and then v squared raised to the 1/3. Then multiply exponents. So u to the what? 4/3, and v to the what? 2/3 power. 2/3. Okay, the next one. Okay, the radical has another radical inside. So let's simplify the radical that is inside. So square root of 2x is what? 2x raised to the 1/2. And then, okay, raise the whole radicand. Raise to the whole radicand to the what power? 1/3 power. 1/3 power. Because this index is 3. So take this whole thing and the 1/3 power. And then multiply what? 2 exponents. 1/2 times 1/3. Then 2x to the what? 1/6 power. Okay, next. Okay, the base is a minus b. The radicand is a minus b. So we can change the radical expression into an exponential. So that will be a minus b. The power is 1/3. Okay, let me rewrite this one clearly. Okay, 1 over 3. Then the bases are the same, so we can put the radicals, the exponents together. So move 1/3 to the numerator, then minus 1/3. Then this is equal to 1/3. Okay, in this example, let's evaluate the function. Okay, when x equals 4. So why don't we plug in 4 for x? So the input is x, that means replace x with the input value 4. So cube root of 4 minus 31. Then the cube root of 4 minus 21 is negative 27. Okay, in this case, the index is odd. So it is okay that we have negative radicand. Then this is equal to cube root of negative 3 cubed. So we can just take the base out. Okay, the next one. Alright, the g of 4 is equal to square root of 16 minus 3 times 4. Then square root of 16 minus 12, square root of 4. And square root of 4 is square root of 2 squared, so that is equal to 2. Okay, here is the domain of radical functions. Okay, so let's say f of x equals square root of x or cube root of x. Now the index nth root of x, nth root of x. So n is positive or negative. So, okay, we're supposed to have n here, n. So if n is odd, do you remember the last time? If the index is odd, then the radicand x can be any real number. This x can be any real number. And the domain is the set of all x values, the input values. So if n is odd, x can be any real number. It doesn't matter, positive or negative. But if the index is even, then there's a restriction. The radicand has to be greater than or equal to 0. It has to be non-negative real numbers. So square root of x. Okay, square root of x, then square is, the index is even, right? So actually the graph of this square root is like this. So the minimum x value is 0. So x is greater than or equal to 0. And the range is also, the minimum y value is 0. So range is greater than or equal to 0. But if the index is 3, like a cube root, then the graph looks like this. So for this graph, x can be any real number. X can be positive or negative. Even the range, the y value is also positive or negative. It doesn't matter. So when we find the domain, always check the index. Check the index. If the index is odd, it doesn't matter. Domain is all real number. If the index is even, the radicand has to be positive, greater than or equal to 0. Okay, this is really important concept. This is also related to the previous properties. Okay, in this example, what is the domain of each function? Okay, the domain is, for the domain, we'll have to check the index. The index is even. This is odd. If the index is odd, then domain x can be any real number. X is any real number. X is all real numbers. All real numbers. That's the domain. So that is the domain. Domain. Let me write D. Domain. So x is all real number. Okay, how about the g of x? This function has even index. So the index is even. And then what happens? The domain has to be greater than or equal to 0. This one has to be always greater than or equal to 0. So the domain, which is the radicand x cubed, has to be greater than or equal to 0. So this implies that x has to be greater than or equal to 0. Okay. So if x is negative number, let's say negative 1. If x is negative, then square root of negative 1 cube is square root of negative 1. Since this is negative, this is not a real number. Not a real number. So in order for the square root of x cubed become a real number, the domain has to be always greater than or equal to 0. The domain has to be always greater than or equal to 0 because x cubed has to be greater than or equal to 0. So x has to be greater than or equal to 0. Okay, in example 9, let's find the domain of this function. Okay, domain, this is a square root. This is square root, which is even. So the domain comes from radicand that has to be greater than or equal to 0. So that's the domain. So domain is what? The radicand is 2x minus 1. So this radicand has to be greater than or equal to 0. Then solve for x. That's the domain. Then 2x is greater than or equal to, okay, plus 1 each side. Then 1. And then divide each side by 2. So 1 over 2. So the domain is, the domain x, domain is a set of all the values that is greater than or equal to 1 over 2. Okay, that's the domain.